Hi everyone, welcome to the first video in the web scraping with Python tutorial series. I'm thinking of making this a two-parter, just covering the basics of the Beautiful Soup package and some good web scraping practices. And I'm thinking of leaving some more advanced topics to like more bonus videos, bonus content, and keeping this series relatively short. Because I think we can cover the basics in just a couple videos. So before I get started, what is web scraping in the first place? So web scraping is basically just grabbing data from the web through the HTML document that represents a web page. So for example, if I open the Wikipedia page here about the 2018 NBA draft, you'll notice that there's a lot of information here that comes in a well-formatted table, and some websites give you download links for those tables and some don't. So for those that don't, you can use web scraping to grab it as well. And the way it works is if we go in the inspector here, so you can open that with Control-Shift-I on Windows, and say we select DeAndre Ayton's name here. You'll notice on the right hand side here, if I zoom in, his name appears in the body of this A tag here. And if we check second draft player, Marvin Bagley, you'll see the same thing, right? So all this content follows this similar path down this tree. So because it's so well formatted, we can grab all this content using like a for loop or list comprehension, which I'll cover later. So yeah, that's the basic gist of what most web scraping is. It's basically just looking through the HTML, finding a way to identify where the information you want is, and then basically just grabbing that information. So yeah, that's basically what web scraping is. Why might you want to learn this? I think I already mentioned this, but not all websites have links to download the data or an API to access the data. So sometimes you have to build the data set yourself. So that's the main reason you need to learn web scraping. Needs a strong word, but it's useful. So I do recommend it. And then in terms of web scraping with Python, when I first started learning, Beautiful Soup was the first thing I ran into. It's best for static web pages, which is what we'll be covering today, when the data is mostly structured, whether that's in a table or something similar to that. Selenium, that one is for more dynamic web pages, so websites that require you to click or like navigate the page in some way to access the data. And then you might be surprised to see Pandas here, but there is actually a really useful Pandas function for when the data is like perfectly formatted in a table. It can very quickly get you that table. So we'll cover that in today's video as well. Okay, so before we start coding, just some prereqs. You do need an IDE, and I do recommend using a Jupyter Notebook or VS Code. And I do recommend using a notebook versus like just a .py file, because web scraping is, I find, to be very step-by-step. There's a lot of iteration, a lot of trial and error. So I feel like the cell format of a notebook fits that workflow a lot better. So that's just my personal preference, but it's totally up to you. But yeah, I do recommend that. The packages, I'll cover which ones you need to install and how to install them. And then prereqs, these are more like soft requirements. You don't really need that much Python or that much HTML. It is nice, but I think this tutorial will be pretty beginner friendly, and I'll be explaining what I'm doing throughout the whole video. So yeah, other than that, let's get started with the first example. All right, welcome back. I've moved to the opposite corner to give you guys some more real estate when I'm coding. But yeah, let's get started. So the first thing you're going to want to do is create a .ipynb file. So you can do that in the Explorer over here. Or you can also just download the files I provide in the description and just follow along. Up to you. Either one works. So once you have that, you're going to want to install these packages here. So in VS Code, you can open the terminal using Control tilde, and then you just want to run these two commands here to install these two packages. So just paste them in and run them. For me, they're already satisfied because I installed them. But for you guys, it might take a couple seconds or so. And once that's done, you can close the terminal. And then we're going to want to import these packages here. Beautiful Soup for scraping. Requests helps us grab an HTML file from a URL. And then Pandas is just for saving our data as a CSV. And regex, that's just a little detail later, so that's also why we need that. So just run that cell. And before we start with grabbing data from an actual web page, I just want to show you how Beautiful Soup works using an example HTML file. So this is also in the GitHub link that I provide below, but I just made this toy example of an HTML page with a couple divs and with p tags and some text. So using that HTML file as this file variable, we're going to create a Beautiful Soup object based on that file, and then using the HTML parser to create our soup object. So let's first print out this soup object and see what it looks like. And you'll see it just returns the HTML of the file, which is what we want. So that's good. From there, there are two main functions you use with Beautiful Soup. Most of the time, I just use this .findAll function. So it does what it sounds like. It finds all the tags that match the one you specify. So if you just run findAll div, whoops, sorry. We have to print because we're within this with block. So print, you'll see a list of the two divs within the HTML file, right? The other one is just .find. So this only finds the first instance. And if I run it here, you'll see that it's just the first div. So that could be useful sometimes, but most of the time when I'm scraping, I want to find all the data that matches a certain criteria. So I usually use .findAll. So let's go ahead and assign that list to this divs variable. And then if you print out again, we have our list. But say we don't want, when we're web scraping, we don't want the actual div tags, right? We want the data contained within them. So in this case, it would be this text here, right? So from there, we need to use list comprehensions. So these are pretty similar to for loops. I just like using them because they save a lot of lines of code and they kind of make more sense to me now since I've been using them for so long. But just to give you guys an example of how this works, let's just run this first. So if I run this, you'll notice it gives you the exact same list back. So what it is doing is you start with a list to start with, and then you're saying for each element, so this right here, in that list, you're going to return something. So in this case, I'm just returning the element itself, which happens to be a div. But you can also call functions and modify it in whatever way you want before returning it. So in Beautiful Soup, you can call .find and .find all on objects that other find all functions return. So it would be like if I just chained these functions together. We are allowed to do that. So this is basically saying if I do .find p, it's basically saying find the first p tag within each div. So if I run that now, you'll see that now the list is just a list of p tags within the div. And we just need one more step. We want the text, so we can just call .text to get the text. And we have the data we want. So now that we covered a basic example using this toy example, let's jump into scraping an actual web page. So going back to the NBA draft wiki page I showed you guys, this one here, I'll also link this below. Let's use that as an example and grab this table here. Okay, so the first thing you're going to want to do is assign the URL you're using to a variable. And then the next thing you're going to want to do is use request to grab the HTML from that URL. Because remember, Beautiful Soup doesn't work on just any web page. You have to first convert it to HTML. So first we run requests.get the URL. And if we print the content, oops, collapse the content. Okay, now that I expand it, you can actually see this is all the HTML from that web page. So now that we have that, we can pass that into our soup object. Again, the same thing as above, we're just placing the HTML file with request.content. And then once we create our soup object, we can print it out just to take a look. You could call .predify to make it a bit better formatted. But yeah, so this looks like what we're looking for. But when you're looking for what to scrape for, you can't really navigate this. This is kind of rough. So what I always usually do is, let's first minimize this with escape O, so that collapses it. I just go to the web page itself and open the inspector. And then, as I was doing earlier, you can just select an element. So we're interested in this table here, right? If we hover over here in the inspector, it highlights that table. So we want to somehow select this here. So if you look at the table tag on the right, you can see it only has a class, so there's no ID, which is a little unfortunate, because we're trying to find the most unique identifier for that table, right? So first, let's just try finding it by this class, wiki table. So if you go back here and copy wiki table, let's just call soup.findAll. So we're looking for tables, right, in this case. And you can specify more identifiers using a dictionary. So in this case, we're looking for tables with the class of wiki table. So if we just run that, we have this long list of all the tables on the page. So if you look, the first one, it looks like this one matches with this small table here. So that's not the right one. So from there, you can kind of just like test out different indices, I guess. I just tried 1 and 2, and then once I got to 2, I hit it. This is not the best way to find it, but sometimes you kind of have to do what you have to do. So if we call 2, now this is the actual table we're looking for. Like you can see Aiton's name in there, right? But this is still kind of a lot to work with, right? We kind of want to narrow it down a bit more. So first thing before we do anything, let's assign what we found so far to a variable. Let's just call it players for the players table. And then next, let's find the rows within the table. So rows, those are the tr for table rows tag. And then let's see if we print that out, what that looks like. Okay, so it looks like there's a bit more structure here, but it's still quite a lot. Let's actually go back to the inspector to take a look. So tr, if we just highlight each tr, you can see that each tr highlights a row, and then the data we want is contained in these td tags. So for each of these TRs, we want to find all the TDs and then finally grab the text, right? That's in here. So this kind of sounds like a job for list comprehensions, right? So we have this row object. So let's start with for row in rows. Okay. So just following the template from before, if you just print this out, we have this exact same thing. And then ignoring this commented out line here, this is quite a mess, but we're gonna get to that. So what do we wanna do with each row, right? So we're trying to grab all the TDs. So we can call .find all TD, right? And let's see. Okay, so now we have a list of rows, and each row is now a list represented as a list of cells or TDs, right? And then now within each TD, we want to grab the text, right? So first thing before that, you might notice the header returned an empty list because it has th tags, not td. So I'm just gonna get rid of that using this notation here. So this is basically slicing out that first element. So if you run that, it gets rid of that. Okay, so we want to grab the text. So we want to use another list comprehension. So let's first remember, this is the list that's returned right here. So we want to create a list comprehension from that. So in this case, let's call it cell for cell in this list. So if we're running it, it's the same thing. But now we have each of these TD objects to work with as this cell variable, right? So we want to grab the text, so we can just call cell.text. Okay, this is looking a lot better, a bit closer to our data, but you might notice there's a lot of these weird symbols like new line characters. Not sure what this is. One easy way to get rid of all these white space and new line characters is just calling .strip. Okay, and great, a lot cleaner, right? So at this point, you can just honestly export the data, but me being a bit nitpicky, I want to get rid of these other special characters. So you can call like .replace and then replace each character individually like this. Oops, sorry, that should be in quotes. And then just call a bunch of chained .replaces. But regex lets us do that a lot quicker. So what we're gonna do is call for regex .sub sub this. So what we want to do is substitute these characters, so the asterisk, and you have to escape it because the asterisk is a special character in regex, or the plus sign, also have to escape that, and also the tildes. So we want to replace those characters with an empty string for all our text, right? So if we call that now, bam, there's the data, right? It's all clean now. You see Luca doesn't have the weird characters next to his name. So that's how we arrived at this whole mess here. So it was a lot of steps, but hopefully it made sense. Feel free to rewatch the explanation if it did not. But now that we have this data, I like to assign this to a variable so we don't lose it. And let's just run this cell one more time. And now our data should be in this variable. The last step now is just to create a data frame and export it to a CSV. So I just did that here. Just call pd.dataframe. Set the data as our data here. It's a list of lists, so basically a table. And the columns, I just copied those from here, and then I just pasted them in as columns after a bit of formatting. I'll leave that up to you guys. One nifty little trick in VS Code is you can do Alt-click to select multiple positions. So that's how I added all the quotes to all these at once. So that's something you could do. But once you have that, the columns added, you can just run df.head, and you'll see we do have our final data set. So from there, all you have to really do is run player df.toCSV, and then you can name it whatever you want. I'll just call it players.csv, set index to false, and then you have a data set to work with. So that was a bit of work, but now I'll teach you guys a shortcut that can save you a lot more time in cases where the table is actually in a table tag or T-body, right? So the trick is just using pd.readHTML. And then all you need to do is give it the URL and then some way to match the table when there's multiple tables. So what I did was I just saw that this table was the only one with the R&D column name. So I just called that. And then if we just run this, let's first print the length of the tables. You'll notice I print that because this function always, no matter what, returns a list of the tables in an HTML. So to get the actual table, you're going to need to index it. So we call 0 to grab the one and only table. And you'll notice we have the exact same data in much less time. You might need to rename, not sure what happened here. You need to rename that first column, but other than that, this is the exact same data as here. So in the future, always check the web page, see if it's already in a table. If it is, use the Pandas function. If it's not, use Beautiful Soup. And next, I'm gonna go over an example where using Beautiful Soup makes a lot more sense. Okay, for this example, we are going to be looking at an IMDb webpage. So specifically, we'll be looking at the most popular movies. So if we look at this page, you'll see that the data is in a table right here, a T-body, but a lot of the data is in the same cell. Like you'll notice the title and the year are in the same TD tag. So that can be a little problematic. And just to demonstrate that, let's just try running the Pandas read HTML function and then read it into IMDb here and then take the first data frame. So using the 0 index, and let's take a look. So the table it gives us isn't super great. And if we want to separate the title and the year, we're going to be using like regex, and I think this is like the rank. So it's like kind of messy, and in this case, it might actually not be better to use the read HTML function. So we're just gonna not use it and move along to using beautiful soup. So first, let's define what we want to scrape. So with scraping, you could also scrape the URLs of images. So if you want to collect like a data set of images, you can also do that. And that's something that you can see here. Pandas can't do because the image URL is in the attribute of the tag and not the body. So it does not grab it here. But we can do that with beautiful soup. So that's the first thing we're going to grab. And then just general scraping strategy again. Let's look for unique identifiers for the data we want to grab. And then we could try to grab one element to make sure it works. That's just a general thing I do. And then you just grab the rest of the data. So again, first thing we want to do is use requests to grab the HTML file and create the soup object. So I'm just going to run this cell. And then let's just run this first. To get the images, let's first get the T body, because all of the data we're grabbing is within this tag. So rather than starting from our soup object and going all the way down, let's just create a variable that starts from the T body. So notice it has the class lister-list. So we can grab that using soup.find. And this is another way that you can grab elements by class. It doesn't have to be the dictionary format. Where was that? Like here, you can do a dictionary. This one lets you define multiple parameters like a class and an ID, for example. But this way is just an alternate way to grab it. So if you grab that, print it out, you see we just have the T body now. So let's try grabbing the images. So one thing that's nice about some websites is they give you a class for all the cells. So you can see here, this cell has the class poster column, and all the other images have the same class poster column, right? So we can just use that to grab the posters. So another alternative notation, you can just not type out class, since it is the second parameter, and soup knows that. So you can just type in the class name, and now we have all the cells with the images. So we're going to do the same thing as before and use list comprehensions to grab the image source. But I'm going to walk through it again just for learning purposes from the start. So let's start with P for P in posters, and that just gives us our original list. So let's see, we want to grab the image first of all, right? So let's go and find image. So now we just have the image tags, and then we want the source. So what we do here is use the .get function. So this one is new. What .get does is it just grabs an attribute within a tag. So we want source, and if we just type source, it'll give us the source. So I checked this beforehand, but if you check one of these links, so if I click it, it's like really small and very pixelated. So I don't know, I just tested this out, but if I remove, this might be too small to see, but if I remove this last section in the URL with this, it looks like it defines the size of the image. I just remove that. There's a much larger image to download. So we can just use the split function in Python. So what that does is it splits the string based on each time it runs into a character that we define. So in this case, underscore. So it'll return a list of all the substrings, and we just want the first one. So in our case, it would be from the beginning up to here, and we want the first one, so that's 0. And then we need to add the JPEG back on. So we just define it with plus .jpeg. And I think actually, oh yeah, I should split it by dot underscore in this case, because there's an extra dot there. So we do that. Let's just define this as image sources. And let's just print out the first 3. Okay, and then if we open this, nice. So we have much better posters. Okay. So now that we have the images, let's try to get another column. Let's try to grab the title column. So I'm going to do the same thing here. Because this is a well-defined web page with actual classes, that makes sense. We can just use the title column class to grab the cells that have the title, right? So let's try that. And yep, there they are. Okay, I'm gonna just uncomment the code this time, since I think you get the general idea. It's the same idea. So we find the A tags and then grab the text, which is the mood title of the movie. And we could print that out just to check. Yep, so they're there. So yours is a little more complicated, but it's the same idea. I'm gonna skip over it, but the general thing is, you'll notice year is in the same TD, but it's nested under another span with the class secondary info. So all I needed to do here was start with the title, but then instead of finding A tags, find, oh, this is another trick. You sometimes don't need to define a tag. You can just give it the class. So I gave it class anything, any tag with the class secondary info, and I grab the text. So if we do that, you can see we grab all the years. Okay, so that is the end of our second example. I'm gonna leave getting the cast to the next video because that requires navigating to other pages. But just to give you guys an intro of what we'll be doing in the next video. So you'll see the cast isn't here, right? It's only when we click on this link that we see like directors and stars, right? So we want to grab them from here, but it's on a separate page. So that's a common like workflow problem you'll run into with scraping, and we'll be covering that in part 2 of this series. So yeah, hopefully this video is useful, and check out the second video to finish this scraping problem.